All right. So what we are going to be learning in this unit, in this lesson in particular, is graphing logs, and really what we're going to be doing is finding the inverse of these complicated exponentials and logs. With the graphing part, we're going to take it a little more lenient, and we're not really going to graph them. I know there's going to be graphs on the notes and the assignment, but when I'm talking about graphing, I'm going to be talking about when we are dealing with, I'm going to write it on this side, y is equal to a log x minus h plus k. That's what we're going to be talking about. So I'm going to be talking about transformations, like what my a means, h, and my k. So now that we're on this topic, let's move a little bit over here. We've seen these letters before, a, h, and k. So I'm going to just go ahead and remind you guys, you know when you have your a is less than 0, it is going to flip over the x-axis. Flip over x-axis. And then when it is greater than 0, it is going to be a stretch. I spelled that wrong. And then when it is in between 0 and 1, it is going to be a compression. In between 0 and 1 means, hey, it's a fraction, it's a decimal, something like that. Then when we are talking about our h is the opposite. So if we have -2, it's going to be +2, the opposite. So when we are going negative, it is to the right. When we are going positive, it is to the left. Usually we would go positive left, but, oh wait. Nope, yeah, I'm right. Positive right. And then last is my k. This one is normal. When I am positive, it's going up. When it's negative, it is going down. So let's continue off with, this is just when I'm asking for graphing, all I'm going to ask is, hey, what is my a, h, and k? That's it. I'm not going to ask graphic because it gets a little complicated and a little interesting. So we're going to just go ahead and save that for another day in our lives. So for inverse, we have done inverse in the past before, not only with quadratics, but with other kinds of units. And so we know the steps to finding an inverse. First step is to switch your x and y. And then second step is, hey, solve for y. Pretty simple. We're going to learn a couple of tricks of how to actually solve when you're using logarithmic or exponential functions in this case. So let's take a look at number 1. So like step number 1 says, I have to switch my x and my y. So I'm going to go ahead and do that. So x is now going to be on this side. I'm going to color code it just for fun. And my y is going to be here. So my x's and y's are switched. Okay. Now I want to get y by itself. That's step 2. So logically want to get y by itself, so let's get rid of everything that is not touching it right now. So it is the 2. So plus 2 on both sides. Okay. So we have x plus 2 is equal to this half y to the this half to the power of y plus 1. Now the complicated part is like, oh no, I have the y in the exponent. How am I going to get it down? So we learned in the previous one, logs and exponentials are inverses of each other. So the way we are going to actually cancel this entire half out is raising it to the power of log half. Same, well, not raising it. It's actually like just being with it. So power log half, right? So these two cancel, leaving me, so I'm going to now write on this side, we're not actually going to use it, leaving me with log half with x plus 2 is equal to y plus 1. So what happens is my y plus 1 ends up coming down because remember, oh, we're not going to learn that until another unit, but it's going to come to the side and all that stuff, but it ends up coming down. Now it's a lot easier. You're like, okay, y is in the same level, it's the same playing field. Now I just need to get it by itself. So all I have to do is subtract 1 on both sides. So here we go. Now, make sure that you do not have these two connecting. You're not going to want to add or simplify or anything like that. When I raised this, when I was doing this log part, it was only to this x plus 2. So I went ahead and put in parentheses. I am not going to include this -1 with this parentheses. It is a different, it's different. So I am not going to include it. We're not going to simplify it. Make sure it is in its separate little bubble. So when it's asking, hey, what is the inverse? This is my inverse. Log base half x plus 2 minus 1. And that's it. So then right away from here, all I'm going to do is name all my attributes. So what is my a for the log? It's 1. There's no number in front. My h, opposite, -2, and my k is going to be -1. Pretty simple. So don't worry about domain and range for these. Don't worry about the graph in that case as well. So all I want you to do is focus on finding the inverse and naming me the attributes of your log function. So let's go ahead and try the next one to make sure I'm aligned. Okay. So again, we're going to go ahead and do step number 1, which is switch your x and your y. So go ahead and do that. This is now y. Now that we have them switched, goal, get y by itself, right? So let's go ahead and get rid of the thing that is furthest from y, which is my 3. To -3 on both sides. So I have x minus 3 is equal to log base 2, y minus 2. So the same thing is happening here. Hey, this y is in between all this mess of log. It's in the parentheses of log. How am I going to get rid of it? Well, same logic that we applied here in question number 1, where I got rid of it using logs, we're going to get rid of a log using exponential. So in this case, we're going to use the power of 2. We're going to use the base of the actual, log base. So this one's to the power of 2. So here, they end up canceling. Do you see that? So then when I bring it over here, I'm going to go ahead and do all my work now over here. I now have 2 to the x minus 3 power is equal to y minus 2. I got rid of the problem where y is in a parentheses and I couldn't get rid of it. Now it's all by itself, well, almost, right? Last thing we have to do is plus 2. So I have 2x to the, 2 to the x minus 3 plus 2 is equal to y. And again, this is my inverse. So I'm going to go ahead and write that. And bam. Again, let's just write our attributes for our log one. So my a, there's nothing in front, so it's a 1. My h is going to be the opposite, so positive 2. And my k is going to be just how it is, 3. Oh, look, 1, 2, 3. So you know you did it correctly basically when you see, hey, I started off with a log and ended it with an exponential, or start off with an exponential, ended with a log. Make sure you're still using that same one. So if I had a base of half, I have a base of half here. Oh, sorry, you didn't see that. Have a base of half, have a base of half. Same thing here, base of 2, base of 2. So that's how you know you did that correctly. And this is it for this lesson. When we're graphing logs and inverses, I know it's deceiving, graphing. We're not actually graphing, but we're just talking about the transformations with AH and K.